Although both Hive and Pig are covered in more depth in other chapters, in this chapter we're simply going to take an introductory look at each of them. We're going to look at their value propositions, compare high-level commonalities and differences, and look at a quick syntax comparison. The reason that both of these came into being is that MapReduce has a big problem. Writing Java MapReduce is just hard. It requires a good Java developer who knows and understands both MapReduce and maybe Hadoop, who understands the business problem, and who most importantly is free. That's a much smaller subset of your overall resources inside your organization. The folks who can oftentimes get the most value out of Hadoop are folks who understand the business problem, the business intelligence or business analyst folks who don't want to be bothered with Java, MapReduce, or whether or not a developer is free. They understand the business problem and they want to go access the data. Hive and Pig are the answer to that conundrum. Each one abstracts out all of the underlying complexity. They expose Hadoop's power either via SQL-like language in the case of Hive's HQL or a data flow language in the case of Pig's Pig Latin scripts. They make Hadoop not only accessible to non-programmers, but even developers can now write queries faster. It may only take 5 minutes to write a Hive query versus 30 to 60 minutes to write a Java MapReduce job. Hive and Pig have several big similarities. Both simply translate a user's query into MapReduce jobs. In the backend, in the cluster, they're simply running a MapReduce job. That translation happens on the client for both Hive and Pig. Hive, however, does need a metastore, which translates its tables into underlying HDFS. If you have several users in a system, you may even want to make that central. Both have server-side web interfaces via either Hadoop's user interface or Hue or the Hive server too. These two technologies can be installed side by side, and many times we'll see a single developer have both Hive and Pig on their client and choose to use one over another in certain cases. Because the code base for both of these technologies is being added to aggressively, both have fantastic performance. In most cases, they're only about 10% slower than even well-written Java, and they're almost always faster than using Hadoop streaming, which may be up to 20 or 25% slower. Both of these are open source and 100% free, and both of these technologies have fantastic documentation and user support. If you ever need to do joins, you should always try to consider using Hive and Pig if at all possible. These two technologies also have several core differences that we'll take a quick look at. Obviously, the language choice is going to be a big determinant of which one you'll use when. More folks know SQL, but actually more developers prefer Pig because it has several constructs, such as for each, that are common in functional programming languages. Hive typically works better with structured data that fits into the row and column paradigm. This does, however, require pre-creation and population of tables. It may actually be better for ad hoc queries, but now with the introduction of Impala, we're starting to see a lot of that use case go to Impala rather than Hive. The folks who named Pig gave it that name because they said it eats anything. It requires no central metastore and it works on raw HDFS files. As opposed to Hive, which requires pre-creation of tables, with Pig you actually load and define the data at runtime. It's typically easier to work with all types of data. If you're like most organizations and you have upwards of 80% of your data is unstructured, Pig can be very valuable. It also gives us more control of the flow of data, and developers who turn to Pig often turn to it for that reason. Let's now take a look at each of these technologies side by side, to not only view each of their syntax, but also to look at their syntax in comparison to each other. This Hive query, which is select location and the average of salary, from the employee table, joining with the department table, using department number, where the salary is greater than 3,000, and grouped by location. I think anybody who's done SQL for more than about 6 months can look at this and understand what's going on. So now let's take a look at the equivalent Pig code required to accomplish the same thing. First up, we see that with Pig, we have to load the data manually. In this case, we're loading this employee file as employee records with the columns location, and we're loading this department file as department with the columns user ID and amount. Again, these two files exist in HDFS. We then go through and run a filter operation, filtering out all employees with a salary more than 3,000, and we're going to do a join. Again, this join right here in either case can be a whole lot of nastiness in Java MapReduce. We're then going to go in and group our employees by location, and then for each grouped by location we have here, we're going to generate a group and grab the average employee salary for that group, finally dumping the result out. Again, it may look like Hive is a whole lot smaller than Pig. It's often slightly more verbose, but remember, in Hive, before we could go in and grab all these tables, we first had to create the tables. If we instead take out all of the load and dump statements from the Pig query, we get this, which is about the same size as the Hive query. Again, Hive is typically a little bit more terse, where Pig is often a little bit more verbose and gives us a little bit more control. In this presentation, hopefully we were able to give you an idea of some of the value propositions of Hive and Pig, some of the high-level commonalities and differences, and a side-by-side syntax comparison of equivalent code. Again, Hive and Pig are covered in much more detail in the other chapters, but here, hopefully we gave you an introduction to these topics.